So today from this video tutorial I'm going to do some simulations regarding logic gates. So let me begin my tutorial first. So all of you know there are some logic gates, right? So we have yes and not, and, or, XOR, NAND, NOR, XNOR, such type of gates. So for these typical gates there are unique truth tables. By using these symbols, actually these logic gates, we develop circuits. Rather than developing this one physically, we can simulate. Actually we can build up circuits virtually by using softwares. Those softwares are called as simulation softwares. So let me show you some simulation softwares which is available for Windows. So some of the simulation software which is compatible with Windows 10 are I have choose some softwares here. You can see one is a Logic Friday, the other one is CEDAR Logic Simulator, actually CEDAR, and this is DEEDS, and Logisim, and digital circuit design, Multimedia Logic, Logic Gate Simulator. So you can see there are several simulators for this logic design because it easy our work. It makes easy our work. We can check the accuracy. We can teach students. Most of the lecturers, teachers use these softwares in order to demonstrate practical lessons, in order to test some implementations. So this kind of simulations are really helpful for us. So let me move on to the interfaces that you can see here. So you can see the Logic Friday, the simulator Logic Friday interface come as like this. So then CEDAR, and then Logisim, DEEDS, digital circuit design, multimedia logic, and logic gate simulator. The interfaces comes like this. So let me move on to the first slide, and then I will be explaining these things by opening the setups and by opening the simulator. Okay, let me start from the Logisim. So you can see here several simulators I have selected. So let me start with Logisim. Actually this is a nice interface. This is basically designed for educational purpose and for the engineering purposes. So there are some nice options available in this Logisim. So actually, first of all, I want to remind here there's a canvas. So, and also we have the panel here. So this was initiated by the copyright and the authorship is belong to Dr. Carl Birch in 2005. Actually, this is an educational tool designed for most of the engineers and teachers, lecturers to perform simulation regarding logic gates. So the interesting thing in here is the users can drag electric components from these folders to this canvas, and they can make electric circuits. So this software was this simulation actually released on 2005. So this is an open source software which runs from Java 5 or the above. So first of all, let me explain the window. So here we have a panel. So we have a file, so you can open a new project or else save. Those items are available here. So again, we can select, delete commands are here. So here we have the tab called project. So in this project we have options such as simulation tree, analyze circuit. So if I get into this analyze circuit, after creating, so initially we will be creating our logic circuit here. after creating, we can derive the truth table. So if you want to derive the truth table, we have to come to this project tab and then click this analyze circuit. Then it will automatically generate the truth table. So here there's a simulate tab option. So after finishing the drawing, you have to check whether this is enabled or not. So you have to enable this one. So let me explain you these folders. Actually here we have wirings, gates, plexers, arithmetics, memory, input, output, base, right? So if you want to draw some wiring, you have to click this plus mark. It's a drop down menu. So you can choose one of these items. It's a ground one, clock one, pulse resistor, tunnel. Any one of these you can click and drag and put into this place canvas. So here we have gates. It should be there should be not gate here. You can see AND gate is there, OR gate is there, NAND gate is there. So we can drag and drop to here. So they have plexers, arithmetic operation, adders, multipliers. Everything's are inside these folders. So what I'm gonna do is I'm gonna do a basic simulation. So here we have the most used ones. It's the normal pinpoint. Sorry, it's a normal hand tool. So here selection tool. This is edit, and this is a pin, and again this is also add pin. Then it's in NOT gate, and this is and this is O. So let me show you some simple simulation. So I will be clicking this AND gate, and I will be just moving the mouse to this side. I am not dragging. I'm just moving the mouse to this canvas, and I will be clicking once. After I click this one, it's automatically shows 5 inputs. So we can control the inputs from this table. How to control? So you can see number of inputs. From here we have to make it as 2. By default it comes as 5, but we have to make it as 2. Also we can label the gates. So this is an AND gate. So I will name this gate as AND 1. So in this label point I have named this one as AND 1. So I will be clicking this place again. So you can see it has a label. Okay, if I double click on this one, again the properties will be up here. So we can change the side of this AND gate. Actually it's heading toward east right now, so I can make it heading towards upward. So how to do that one? So you have to come here. It's facing is east, so I can turn this into north. See, now it's turned to north, but in my case now I don't need this gate at the north side, so I will be turning it into east side again. Okay, so I have added a one AND gate. So I hope to add another AND gate by clicking in that folders. I'll be putting one AND gate here and another OR gate. So you can see by default they have 5 inputs. So initially I'm gonna name this one as AND2, and 2, and then the number of inputs as 2. Now it's okay. So this OR gate, I'm going to name this OR gate as O, and I'm going to reduce the inputs to 2. So you can see I have created the base 3 logic gates, and now I'm going to fasten these 3. So when you move the mouse pointer here, you can see it getting circled. So you have to click that point and drag and just stop from here, and then you have to click from this point, just drag and join. I recommend you to just start from 2 places, because you have to drag from this point and come to here and then stop. Again you choose this point and then join this point. I recommend not to don't actually don't fasten this line at once. If you fasten this line at once, sometimes these ends might not get connected. So what I do is like I will fasten from this end, and I will draw a wire from this end, and then I'll fasten this one. So also here another one. So for the inputs, I'll put a small piece of wire line. From here also another piece, from here also another piece. Okay, now I have completed my circuits, and now I want to input. I want to fix inputs. So as inputs, I'm gonna fix a switch from here and another switch from here. So I can copy paste this one by CTRL C and CTRL E. Then I can put it here. Again CTRL V, again CTRL V. So I need 4 switches. For my circuit. Okay, now I'm going to fasten these ends. So what I'm going to do is click this end, and while clicking I'll be dragging the positions. So you can see when I'm connecting these two, the colors of the wires will get turned into green color. So I'm gonna make the end. So in the end point, I'm gonna make the end point as a LED bulb. So let me check. This is the input output folder. So in this one I have LED. So I'm gonna click this one, and I'm just gonna click again in here. So and again I'm going to fasten the end. Also I want to just take the readings. So I'm going to click this add here, the pin in here. So I will be placing one pin in here, and another pin in here, and another pin in here, and I'm gonna just fasten this end to this wire, this end to this wire, and this end to this wire. So now my logic circuit is almost completed actually. So what I want to do is now I want to simulate this one. So I will be checking the simulation is enabled. Now what I have to do is if I click this one, before clicking you have to change the tool, so to this hand tool. Okay, now I'm going to simulate. If I click this one, it press as 1. If I click this one, it press as 1, active high stage, active high stage. So AND gate means it's a multiplication. 1 into 1 passes the value as 1, and it comes 1 to here, and from 0 0 it comes 0 for this stage, and value is passed to here, and 1 plus 0 is again it's 1. The signal which passes through this wire is active high stage, so the LED bulb will lit. So this is one kind of simulation that you can do from this Logisim. So I'll show you again. So I'm going to switch off this one, switch off this one, and I'm going to switch on this, switch on this. So at this active high stage this bulb will light up. So I'm going to switch off this one and switch on these two. So then also this will lit up. But if I switch off this one and this one, you can see the bulb will not lit up. So for this one we can generate the truth table. In order to generate truth table, now I have 1 2 3 4 5 6 7 8 outputs. It's complex, so I'm going to remove some outputs. So I don't need these pins. I'll be deleting these ones. Okay, this is okay. So for this one I'm gonna name and label this one as A. From here you can label it. then click here, double click this one and come to here, can label this as D, again click the canvas, again double click this one, you can label this one as C, and then come to canvas, double click this one, name this one as D, come and click in this canvas. So for output, double click on this one, name this as X and click. So I have inputs A, B, C, D, outputs as X and the LED bulb. So at the moment I don't need the LED bulb also. I will delete this one. You can delete this one by right click and delete. Also, if you want to zoom in and zoom out this canvas, there's an event here. So you can see left side at the bottom stage. If you press these buttons, it will get zoom in and zoom out. Okay, now I'm gonna derive the truth table for this one, this logic gated, this sequential circuit. So what I have to do is I have to go to project, analyze circuit. You can see the output inputs here, right? Or else I can go to project, it's analyze circuit. So you will be getting a window like this. So what's in here? So we have the expression A, B, C, D and the table. Here is the output table, the truth table actually. So I'll be dragging it here. So you can see I have 4 inputs. For the 4 inputs, these conditions are the true places. So let me check if C and D are active high, the output also active high, right? It's correct. So in the initial stage, if this one and this one is active high, the LED bulb lit up, right? So this confirms our logic gate. And also if you want to build a nice one according to the standards, if you press this build circuit, it's okay, they will be asking to replace. I said yes, so it will be nicely arranged and they will be giving an output. So this is some nice features from Logisim. So I will be moving into next simulators. So the next one is Logic Friday. So you can see the interface is similar to not similar to the Logisim. It's actually it's an open source software. So the Logic Friday is works for Windows 2000 and above. So this was released on 17th of January 2013 actually, and this is also widely used by the engineers and the teachers. So let me show you the functions. If you want to make a circuit, you have to go to new and then you have to choose that, or else you can do truth tables, or can design logic gates, or else equation, or else logic diagrams. So I'll be focusing on this gate diagrams. So if you click that one, you will be seeing a panel here. So from this panel you have to select the gates. I will be selecting AND gate, and again another AND gate, and another OR gate. So you can see here 2 inputs OR gate, 3 inputs AND gate. So inputs are mentioned in here. So I want to fasten this one, so I will be clicking this one, this wire, and I will be clicking here, and I will be clicking the other point. Here also I'll be clicking this point and fasten this end, right? So I want to input. So in here we have input items. From these input items, If you click this input, I can take the input as A. By default it shows as A. Again another input, by default it's B. Again another input, C. Again another input as B. So again I'm gonna fasten these ends, inputs of A to this logic gate, B to this logic gate, and C to this logic gate, and D to this logic gate. Okay, I'm gonna just adjust these things. Okay, so I wanna draw the output, so I click this output and I'll be fastening this end to here. So output is named as FO. After drawing this one, what I have to do is I have to submit. Press the submit button. After submitting, it will show the relevant outputs and the truth tables and everything. So Logic Friday is so here it has derived the equation also. So let me move into the other one, CEDAR Logic. I pronounce it as CEDAR Logic. So actually this CEDAR Logic is much similar to Logic when it compared. So when we are comparing a simulator, what you call the Logisim simulator and CEDAR, both have similar properties. This CEDAR is a interactive logic simulator, so mainly used for this is teaching and testing purposes. This can perform both high logic level and low logic level components. So I will show you how to work with this one. So similarly, here we have panels and basic gates, inverters, input output option, decoration, multipliers, decoders, adders, flip-flops, registers, right? So we can perform anything by clicking these ones. See, you can see it will be changing. So I'll be selecting the basic gates. I'll be selecting in here you have to click and drag while clicking and drop it. Again I will be clicking and dragging and I will be dropping it here, and after that I will be just give a one click. After that I will be selecting a OR gate, click and drag, I will be putting it here, right? Click it. So I'm gonna fasten these ends. While fastening, there's nothing to worry, so you have to just click the both ends, so it will automatically get fastened like this. I'm gonna add input devices. So input, I'm gonna add a switch. You can see I'm gonna add a switch. So in this switch I will be adding it here, another switch in here, another switch in here, and another switch in here. So I'm gonna fasten this switches also like this. Click and drag, click and just connect, so it will be connected. So for the output I'm gonna fix an LED. See here, you can there's a LED here. So what you have to do is click and just place it here. For this LED you can connect from the four sides. Inputs can be connected from the four sides. So I'll be fastening this end. Okay, so I have completed my simulation. So what I'm gonna do is I'm gonna activate this now, right? So if I want to activate, if I press this one and this one, the bulb will light up. If I switch off this one and then if I make this one as active high and make this one as active high, the bulb will lit up. So this is a CEDAR, it means CEDAR Logic simulator. So let me move on to the multimedia logic. So similarly, this is also have some kind of canvas, so we can draw it in this canvas, the logic gates. What we have to do is we have to take logic gates from, we can take logic gates from this draw option. You can see input devices are there, output devices are there, nodes are there, wires are there. Also we can take the logic gate from here. I'll just draw a simple logic gate. See, after clicking this one, you have to press escape, or else if not, it will be replicated. If I click on this pattern, and if I click here, and if I click somewhere again, it will replicate, it will reproduce. So what I have to do is, after clicking this panel, I don't need to drag, I just come here and just click, and then I have to press escape in order to cancel the query. So this is a much complicated one. So this multimedia design is an open source logic design system, this software, right? So this has some kind of a separate tool to debug, and also this was released on January 22nd 2004. So let me delete these unnecessary items. I will be keeping only 2 for my simulation, and I will be deleting the other one. We have to right click and delete, right click and delete. So I will be dragging another OR gate. I'll be clicking here and I'll be pressing escape, and again I need to fasten the ends, so I will be taking this wire, I will be fastening by double clicking. Here also I have fast. Also I want to connect an input, so I'm going to draw here input devices. I'm going to put a switch. Okay, then press escape. So I want to drag this switch here, right? I want copies, or else if I have the switch, I want to select it again, input devices, switch 1 2 3 4, right? Then I'll press escape. So now I have 4 switches, right? So now I will be connecting these 4 switches using these wires. This to this switch, this switch to this AND gate, this switch to this AND gate, and this switch to this AND gate. So then I want the output. I will take output as a LED bulb. So in output devices, you have to go to draw. In output devices, you have to choose LED. Just click here, press escape. What you have to do is maintain it here, and you have to join. Right, I have completed my circuit, and I'm going to start the simulation. So what I have to do is I have to click this simulate and press this run. Okay, now the canvas has gone. Now we have only the circuit. So if I switch on this one and this one, the bulb will light up. So you can see the red color. If I switch off this one and this one, it means active low, 0 0. So this one active high, this one active high, the bulb will light up. So similarly, this is similar to the prior one. Actually, it's CEDAR. So let me explain another software, another simulator, DEEDS. I like DEEDS software very much because it's kind of it has some kind of attractive surface interface, and it is much similar to Logisim. So in here we have the panel, simulation panels, items. So what I'm gonna do is I'm gonna add an AND gate add another AND gate, right? And I'm going to add another OR gate like this. Then I'm going to add input switches. One. I'm going to label this switch as A, another switch it as B, another switch as C, another switch as D. Also, I'm gonna add the output device from here, right? We can add a LED bulb or else just LED. First of all, I would like to join this one. You can join using this option here. Press escape. Again, click here. Just drag from this end. Click here and drag. This end, click and connect to this end. Okay. Now I'm going to connect these two also. We have to take this line command. Okay. From here also, like this. I have completed my circuit. Now I have to add an LED. I'm gonna add an LED for this one. So what I have to do is click here. I will be adding a test LED. I'll be placing it here and I'll be fastening these two ends. Okay, done. My circuit is now almost completed. After completing, what I have to do is I have to go to the simulation tab and then start animation. So they will be asking to save. I'll be saving this one. After saving, I can start my simulation. So if I make this one as active high and this one also active high, observe the LED bulb. LED bulb turn into blue, right? I will be switching off this one active low and this one also active low. This I'm going to switch on this too, and then the LED will light up like that. I'm going to switch all the things, all the switches at marked as active high. So you can see the LED is lit up. So then I'm going to switch off this one and switch off this one. LED won't lit. So this is DITS, actually Digital Circuit Simulator. I personally like this one because it is much similar to Logisim. So that's all about simulation softwares. I have choose these simulation softwares. So thank you all.